This is what many people will do when they see a question like this, because it looks complex. But let's name this alkane together. Welcome to Chemistry Mayor. Let's do the nomenclature of this alkane without taking much time. Now, we know the rules that guide the nomenclature of alkane. The first thing you do is to discover the longest continuous carbon chain, either straight or branch. That's the first thing. So we need to find the longest chain. And it requires a lot of counting for a beginner. One can say 1, 2, 3, 4, 5, 6, 7. Just 7 carbon atoms. Yes, another person can count 1, 2, 3, 4, 5, 6, 7, 8. Okay, this gave us 8. The straight chain is off now because it gave us only 7 carbon atoms. Okay, there are so many chains, so many of them. We can still start from here. This is a chain 1, 2, 3, 4, 5, 6, 7, 8. So this gave us 8. Now let's check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the 8s are gone because we now have this giving us 9. But before you conclude, let's count one more. I have a chain starting here. This chain can run from here to this place. Okay, let's see the number of carbon atoms here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the word 10. I don't think there is any other chain longer than this by the time you look at this. So now that we have discovered that this is our longest chain, any other group that is not part of the chain is a substituent group. So let's identify the carbon atoms that we did not count. That's the groups that are not part of the chain. This is one of them. When we are counting, we did not count this. Now this is another one. When we counted, we didn't count that. So this is this. So this is part of the chain that we did not count. That's part of the carbon atoms that we did not count. We didn't count this man. We did not count this beautiful lady. We didn't also count this handsome boy. And we did not count this. So look at our chain. So the moment you are able to identify the longest continuous carbon chain, the next thing you have to do is to take note of the word, of the groups that are not part of the word, that are not part of the chain. These groups are called what? The substituent group. Then once you have done that, remember the first step, identify the longest continuous carbon chain, either straight or what? Branch. Because the longest chain may not necessarily be what? A straight chain, as we can see here. Okay? Then when you do that, circle the ones that are not what? Part of the chain. That's what we call the substituent groups, or the what? The attachee. We call them attachee. We attach them to the chain. Just you can see this attached here, this attached to the chain, this attached to the chain, attached to the chain, attached to the chain. So when we finish the 2 steps, the next thing is to number the carbon atom, right? Number the carbon atoms in the parent chain. This is our parent chain now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that 10 carbon alkane is called what? Decane. So the parent name or the main chain here is decane. Okay, so where do we number from? Let's see if we number from here, because when we number, we usually take the least position. So if we number from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's check the positions of the substituent group. Coming here, this position 4, this one position 4. So 4 plus 4. Okay. Then this is position 5. So we have plus 5. Plus again. Which other one? This is position 7, position 7. So 7 and 7. Plus what again? This position 8 and 8. Plus 8 plus 8. Did we miss anyone? 1, 2, 3, 4, 5, 6, 7. Okay, let's check 1, 2, 3, 4, 5, 6, 7. So we didn't miss any of the position. Position 8, 7 and 7, position 4 and position 5 and position 4. So if you find the sum, 4 plus 4 is what? 8. 8 plus 5 is what? 13. 13 plus 7 will give us what? 20, 27. 27 plus 8 will actually give us what? 35. And 35 plus 8 will give us 43. So the total here gave us 43. But if we decide to number from the other end, because we have 2 ends here, so let's take away this. You know, that's for a beginner. When you are a beginner, you do this numbering. But once you have advanced in it, you know where the numbering will begin, because we number from the end that has most of the substituent group, like here. This place has most of the substituent group. and our number is supposed to start here. But let's still use this method. So we have 1, the first carbon here, 1, this 2, position 3, position 4, 5, 6, 7, 8, 9, and 10. Now let's check the positions. We have positions 3 and 3 for this and this. We have position 4 and 4, right, for this substituent group and this substituent group. Then we move, we have position 6, okay? Then we have position what? 7 and 7. I think it's complete. 1, 2, 3, 4, 5, 6, 7. Okay. 3 plus 3 is 6. 6 plus 4 is what? 10. 10 plus 4 is what? 14. 14 plus 6 is actually what? 20. And 20 plus what? 14 will give us what? 34. Wow. 34 as against 43. You can see that this is smaller than this. So the correct numbering will start here and not from here. So this is our correct numbering pattern. This is where we are going to number from. If you look at it just by speculation, you discover that the substituent groups are closer to this end than here. We don't have much substituent groups to this end as when compared to this one. So now that we have seen where to number from, the next thing is to name the alkane. You identify the name of the substituent groups and identify their positions, and then already we know the parent name. If you combine all of them, you now have the name of the alkane. So we have two different substituent groups. Both of them are alkyl group, but they are different. This one is methyl, this is ectyl, right? So we need to take note of their positions. But remember that when you have different substituent groups in an organic compound, you arrange them in alphabetical order. So methyl, and ectyl. In the English alphabet, E comes before what? M. So we are going to place the ectyl first before what? Methyl. So let's start with the ectyl. I have an ectyl here at position 4. I have another one at position 6. And I have another one at position 7. So what are their positions? Position 4, position 6, and position 7. Look at them. Position 4, this ectyl group. Look at another one, ectyl group, and look at another one, ectyl group. So that's their position. Now we know in the nomenclature we separate number from number using a comma, and we separate number from letter or number from word using what? Using a hyphen. So now that I've written this substituent group occurs 3 times. So we use the prefix tri to show the number of times it occurs. So this is going to be what? Triectyl. So triectyl. So 4, 6, 7 hyphen triectyl. Because we cannot say 4 ectyl, 6 ectyl, 7 ectyl. That would be clumsy. So this tri is showing us that they occur 3. It occurred 3 times. So 4, 6, 7 triectyl. Then the next substituent group will now come, which is methyl. These are position 3, position 4, and position what? 7. So we now write 3, 3, 4. Where is the 4th one? The one at position 4. Then this at position 7. Then hyphen. Now how many? 1, 2, 3, and the 4. That is tetra. This prefix tetra will come in. So tetra, methyl, then the parent name, decane. So the parent name is the suffix at the end of the day. So we place these names of the substituent group together with their position, then before the parent name. Remember, there should be no space between them. So this compound is actually 4,6,7 triectyl 3,3,4,7 tetramethyl what? Decane. That's the name of this particular alkane. See you in the next class. Make sure that you like this video and also comment and also share. Follow for more because we have more meals from what? From Chemistry Mail. Goodbye.